Hi. I wanted to record this video today because I found a video which made me genuinely upset. I probably should not be, but it's about AI, and I show you the title. So the title is How Agents Quietly Break Architecture. So we are going to watch the video and I will take notes and I will tell you what I think afterwards. Because for me, who has been programming for a very long time now, 25 years, I'm not happy with what I'm hearing in this video.
My problem with agentic coding is that the agent can keep shipping changes long after you have stopped understanding the system. You start your project and are full of ideas of what is possible, what your application should do, how the different pieces might interact, and where this whole
Actually, I should probably restart the video and raise the volume. Sorry about that. Let me check.
My problem with agentic coding is that the agent can keep shipping changes long after you have stopped understanding the system. You start your project and are full of ideas of what is possible, what your application should do, how the different pieces might interact, and where this whole thing could go. Maybe you take the time to come up with a spec for your intended system and its desired behavior. By doing so, you go back and forth with yourself and or an LLM to nail down the semantics, boundaries, contracts, and feature set. At this point, things still feel manageable. You have the high-level idea in your head, some kind of written reference, and a rough sense of what the system is supposed to do and what it is explicitly not supposed to do. So you start your work. You create dedicated work packages for agents to handle, potentially split up into smaller slices so each task is manageable on its own, without necessarily creating a 1000-line diff. In the beginning, this works well. Agents perform well. You let them generate tests. You review their code or are confident enough in their ability to let another agent do the review. You might even come up with your own tests and implementation details on how things should explicitly look. In the process of working on your application, you are confronted with issues in behavior, things you missed when speccing things out, and areas where you were simply not explicit enough in your design. No problem yet. You still have an idea about what your system is supposed to do. This is what your spec is for. You might adjust the plan and let the agent fix the immediate problem and move on. And for a while, this feels completely reasonable. You keep working and things start to come together into something usable. But at some point, you reflect on your work together with your agents and might get a weird feeling. A feeling of being out of touch with your actual implementation. Not necessarily because the code or the architecture is bad, and not necessarily because the agent did something obviously stupid, but the system has kept moving. Specs, edge cases, implementation, tests and assumptions have changed. And even though every individual step may have looked reasonable, you now ask yourself, do I still actually know what the system is supposed to do? I purposely want to leave out any broad remark on code or architecture quality here. Today, I do not want to talk about whether applications built with agents are good or bad. I want to talk
I want to make a little pause here because there is a really big problem if you're asking yourself if you still know what the application is supposed to do. There should never be a case where you develop an application and you don't have an idea what the application should be just because you delegated the work to an AI agent.
about an approach for not losing touch with your actual system. I want to talk about using formal models as a way to keep the intention of a system from becoming just another stale prose document next to the code. The project where this became concrete for me is an agentic video editor. The basic idea is that the editor should not only manipulate a timeline once the relevant clips are already there. It should also be able to reason over large media libraries. That means the agent needs tools for finding relevant material inside potentially huge catalogs of videos, audio, images, transcripts, documents, and derived features. And it should not only retrieve whole files. If you ask for a specific moment, sentence, action, visual idea, or section, the system should be able to retrieve the relevant part inside a file. So we are not only interested in which media file is relevant, but also which segment inside that media file is relevant. That distinction matters because the editor does not just need media search. It requires media search with something I will coin sub-media precision now. For that to work, the system has several moving pieces.
And here I want to say that I totally understand why you would want something like this. Over the past month, I've generated a lot of live videos when I was streaming, and I need a lot of clips from these videos. And if I had an AI system to retrieve the content that I think I need to make shorter summaries or design analysis, that would be great. So having an agent to retrieve from like 30 or 40 videos the clips that I need and I remember that are in those videos without manually searching, that would be great. So I understand why you need a system like this.
I will try not to bore you with the details and limit this to the bare minimum needed to highlight an issue I encountered. There are 4 high-level components that make up the system. 2 of them are especially relevant: a searcher and a featureizer. The featureizer is responsible for making a potentially terabytes-large media repository digestible and queryable. The searcher uses these results to resolve semantic queries over the media catalog. Both of these components and all other components in that system rely on the same holistic meaning. The searcher does not only rely on the featureizer, treating assets the same way as the searcher itself. During the development of all modules, these invariants have to be preserved across the whole system. In other words, if one part of the system thinks something is a temporal range, another part should not quietly treat it as a single point. And if one part treats something as point-like, another part should not quietly turn it into an interval just because that makes a test easier to satisfy.
Okay, so this part of the video is a little bit bad because it's introducing the main idea of the video without us knowing what is it talking about points and temporal ranges. So his introduction here is just confusing, but that's not, that's not super important because it's well explained a bit later on. But when you come to that part, you're just wondering what is he even talking about.
This already highlights something I had internalized subconsciously, but only became actively aware of when I started integrating agents into my development process. Local correctness does not guarantee global architectural alignment.
And here, this is completely wrong. Local correctness has nothing to do with global architectural alignment. I will explain why I think so. It's just wrong to think along those lines. And actually, I should make a note of this. Let me make a pause real quick. So here, what he's saying is local correctness doesn't guarantee global architectural alignment. This is a bit harsh, but there is no word for it. It's just nonsense. I know what he's saying in the video, and I can see why he would say something like this, but it's just wrong. The idea is just wrong.
I want to try and make this visually clear. Imagine our system as a puzzle. The puzzle pieces have tabs, the outward connectors, and blanks, the properly shaped holes they slot into. A localized module gives us the shape of each puzzle piece. This is all fine and good as long as we do not have a second layer of invariants we want to preserve. We can visualize that second layer as a circuit grid, the image, so to speak, printed on top of the puzzle pieces. From what I have experienced so far with AI and from examples and experiences I have gathered from other people, AI is pretty good at preserving the shapes of puzzle pieces. But it gets creative when it comes to preserving the overarching, non-localized global semantics of an intended architecture. We will get to the specific bug I want to use as an example in a second, but for now, staying with this visualization. What I want is this. 6 puzzle pieces, fitting together perfectly, laid out according to my specs. Depending on how rigorous I am in my definitions, the AI might still preserve the local shape of the pieces while deforming the intended picture on top of them. So the result can be structurally correct, but semantically malformed. I will give a specific example that I encountered during development. The system has to distinguish between media that occupies time and media that only has a position or identity. For example, video shots, audio spans, or transcript segments can be considered range-like media. Images, still frames, or representative frames can be considered point-like media.
So you see here he's explaining what he was talking about before with the ranges and the point-like nature of each media that is going to be searched in the system.
A video shot exists from T0 to T1. Same for an ASR segment. But an image does not exist from T0 to T1. It may be associated with a moment, but it is not a duration. And this distinction matters semantically.
And this here is why I disagree. Because if you want to represent the data, you have many ways to do it. So a time range would be like T0 to T1, something like this. Okay, a point in time will be just T. Okay, but if you want to have an uniform format for every piece of information, you could also say that, okay, a keyframe inside a video will be just a timestamp. So that will be T with a duration of 0. And that would also work, right? So if you take a slice of the video, you will get a T, the timestamp, and then you will get a duration of, I don't know, 23 seconds. Right? So this here can still be a keyframe, point in time, an image inside the video, and this is a slice of the video. So with the same data structure, which is I don't know, time data structure, I don't know how to call it yet, you can get start time and you can get a duration. And if the duration is 0, it does not matter, it's the same data structure. So even though semantically as a human you can actually have different data structure, for example a time range, a point in time, or a start time and a duration, it's up to you to define what the data structure is and then do something with it. But there is no concrete way to arbitrarily say that only this is correct, because this can work too. Okay, so that part of the video is just wrong, and I'm not happy to see that. And I will explain why later on.
A visual frame may be associated with one moment. An ASR segment covers a range. So if I want to relate those two things, the concept is not, do these two intervals overlap? The concept is, does this point lie inside this interval? That distinction is small in English, but it matters architecturally. So what happened? An agent fixed a failing test inside the searcher. Because tests can sometimes be interpreted in multiple ways, it fixed the test by collapsing a distinction the architecture needed to preserve. The agent optimized for the localized shape of the module. It fixed the visible failure, but it did not preserve the architectural invariant. And this is the kind of problem that is easy to miss.
And here, as we can see, there is no architectural invariant because it did not define what a time range or a point in time or a time with a duration is. Those data structures are not defined in whatever he used to define the problem for the AI.
You could argue that this is fine because it did not violate the module's local contract. But I have two problems with that. First, I do care about that. Second, these things compound over time and can contribute to code bloat in later extensions. Even worse in my eyes. The diff was not obviously insane and the outward-facing behavior was locally correct. The test passed. It made it possible to confuse point-like temporal information from images with range-like temporal information from videos. Not externally, but the next agent that has to extend, improve, or change this module might see that part of the fixed code and suddenly infer that it is okay to apply that constraint elsewhere. It is not the dramatic version where an agent destroys your project. It is the version where it makes a reasonable local change that slowly weakens the meaning of the system. And depending on your development velocity, things like this either surface quickly or they slip through the cracks and become part of the architecture by accident.
So this point here is something that is certainly true if you're working with an AI, but it doesn't matter because it happens also if you're working with real people. If the problem is not correctly defined and there are mistakes, architectural mistakes in the solution, eventually things will compound and a rewrite will be necessary for some parts of the project. So it has nothing to do with AI. So that's why I don't like the video. It could have been a good engineering video about software engineering principle and software architecture, but it's conflated with AI when those problems have nothing to do with AI. And that's what I really dislike.
Before you know it, you might end up with seeds of wheat that might thrive and spread from localized change over more iterations to more and more parts of your system. Agents are good at coding, and generally I have had and still have a good experience with them. But at least to my tiny brain, I cannot shake the feeling of sitting in a sports car at Le Mans with the accelerator set to max by default. The car is powerful. The problem is not that it cannot drive. The problem is that every small steering mistake now compounds faster. To help me with situations like this, I move semantic, architectural, and formal ambiguity into lean. Because prose was no longer forcing me to decide what the concept actually meant.
And here we have an issue because he's introducing a term called lean, and there is no definition what he means by lean. Correct? I watched the entire video already, and there is no explanation what he means by lean. So this is a mistake.
Even more so, prose was not able to enforce it downstream. I like lean and picked it up because it allows me to have a compiled formal model of my system. For me, that model acts like a condensed view of the global architecture that matters. Since it compiles, I can add its build step to my test pipeline and require agents to touch it when architectural changes need to happen. When they inadvertently try to change something that works locally for a module but breaks the global architecture, it becomes a compile error in my spec. I can take a look at what invariants were touched and reason from there.
So here, if we're being smart about it, we may be able to understand that lean is some kind of, I don't know, technique or project that makes architectural changes visible, and you can put a constraint so that when the AI works, it does not break the architecture. I suppose that's what lean is.
We gotta stay real here though. Even with lean, there's no guarantee that the implementation always matches the intention. But at least I feel a little more at ease when an agent makes large changes in my codebase. By the way, coming back to the bug at hand. I made the missing distinction explicit in the formal model. Before this, the model already had a relation for temporal overlap. That relation is for the normal interval over interval case. A video shot overlaps an ASR segment. An audio segment overlaps another temporal segment. Both sides have a start and an end. But the bug was not really about interval overlap. The bug was about a different relation. A temporal point lying inside a temporal interval. So the formal model changed like this. And we gotta focus on this new relation. Temporal point and interval. It is pretty obvious and bears not much meaning by itself, which is good. A spec is, after all, not intended to be complex. I want it to be straightforward and simple. It is the model saying, point and interval is its own concept.
And here, again, we can see that he's making an assumption in his head that the AI does not know about. So the AI can do whatever it wants, and he's surprised when the AI comes up with a solution despite not giving it the constraint that he has in his head. So he doesn't design or provide the right intent, and he's surprised when the code does not follow the design rules he has in his head that he didn't put down in the system.
And then the model defines when this relation is even well formed. Temporal point and interval is only well formed if the left side has a temporal point and the right side is a temporal interval, or the other way around. And in plain terminology, the law is, for the same media item, the temporal point has to be contained within the interval between t0 and t1. What the agent did while making the test work was different. It added an extra if statement that coalesced a temporal point into a range interval. The shortcut was to let the implementation blur point-like temporal information and range-like temporal information together.
And this is not wrong. You can, as I just showed here, there is nothing wrong with doing this. Conflating a point and an interval, if the duration is 0, it's the same thing, fundamentally, so the AI did its job there. I see nothing wrong.
The model forced me to name the missing relation instead. And once the relation had a name, I could tell the agent to align the implementation with the formal specification. This rhymed. That alignment showed up directly in the Rust code. The implementation also got a new relation intent. And when that relation is lowered into executable behavior, it does not become interval overlap.
Also notice that in this case, the code becomes more complex because instead of having a single data structure that can handle any case, now he has code for two different data structures, which is more complex and can also lead to errors and bugs in the future. Probably not, because we are talking about something that is relatively simple here, but in many other cases, if you have the possibility to collapse into a single data structure that is yet simple and elegant but handle more cases, maybe that's something to consider, because This means less data structures, less code, less maintenance, and less overhead at the end of the day.
It becomes point within interval. The actual relation construction now reflects the same distinction. First, the implementation checks whether both sides are intervals. If they are, this is temporal overlap. But if that does not apply, it falls through to the separate point and interval relation. And that relation has the same shape as the lean model.
You see here, instead of having a single test to check whether there is an overlap, now we have an if-else to handle two different cases when we could do one single test for any possible data that we receive when we want to check if there is an overlap or not.
Point on the left, interval on the right. Or interval on the left, point on the right. Anything else is not this relation. And at execution time, that becomes the concrete predicate. Even the boundary condition now follows the formal terminology. So the final code is not just the test passes now. The final code preserves the concept. Temporal overlap is interval to interval. Temporal point in interval is point to interval. And those are different relations with different well-formedness rules. I could ramble on about how you can even use the formal spec to let agents derive semantic tests that aid in preserving the formal model, but that might be something for another video if anyone cares. Why agents change the economics?
Okay, even this is kind of wrong because there is nothing about economics here. It's just software engineering. There is no economics there.
Agents changed the workflow for me. Before agentic coding, it was much harder to justify maintaining a formalized spec together with the implementation. Not because the idea was bad, but because the maintenance cost was real. Maintaining the implementation, writing new code, changing old code, and adding new or updated tests is already a whole workload by itself.
And here we can see the real problem. It does not want to do the upfront work, which is to document and write the test necessary to ensure that the model is correct. If the problem you're trying to solve, you do not have a correct mental model of it, and you do not use the correct classes and data structures or even database to model the problem, you're going to have issues. And because it did not want to do that upfront work because that's too much maintenance for him, then he runs into the problem that the AI can do whatever it wants because it's not defined. What a surprise.
Trying to keep a model up to date alongside that usual workload was something I had only done for certain components where correctness and security were hard requirements. So in practice, I would often keep formalization more minimal than I actually wanted. But with agents, that trade-off changed. I can spend more of my attention on making sure the model is correct. I can focus on the compressed reference point. What are the concepts? What are the laws? What distinctions should the architecture preserve? And once that is clear, I can use agents to help propagate those changes through the implementation. And that is a very different relationship to generated code. The agent is not where I want the truth of the system to live.
This is the only place in the video where I agree 100%. The model is the truth, okay? The agent is just generating code, but the truth is in the data. And you will see why I'm saying this right now. So the model holds the truth. The data has the truth, not the code.
The truth should live in a contract outside the agent. And the agent helps me keep the implementation aligned with that contract. So instead of constantly trying to hold every implementation detail in my head, I can keep coming back to a smaller, denser representation of what I intend to build. At least, that is how I stay in touch with the system. The implementation details still matter, but they become relevant fewer times. They're no longer the only place where the architecture exists. And this is where I think this approach fits into a broader evolution towards spec-driven agentic development.
And here is doing something dumb again, is inventing a word like spec-driven agentic development. Like, what does this mean? There is only software engineering. There is no spec-driven agentic development. That doesn't exist. It's either you do your job as a software engineer or you don't and you have problems. Agentic has nothing to do with it.
Prose specs are not useless. They are still the best place to explore the idea. But prose does not compile, and that is my biggest issue. It can become quietly stale.
Yes, and that's why, as a software engineer, you go to the stakeholder or the consumer, you ask questions, you revise the design, you write user stories, you make an implementation, you show the implementation, and you go back and forth. That's how software development works. Why do you suppose that your prose spec is going to magically stay up to date with the code if you change the code and do not revise the user stories when the design change and they're wrong? There is nothing magical about this. It's just software engineering. It has nothing to do with AI.
You can change the implementation, the tests, and the architecture. And the prose spec can still sit there, looking like it means something, while no longer being an accurate representation of the actual system. Lean does not replace the prose spec. It is orthogonal to it. The prose spec is where I explore the system. The lean model is where I force the important parts of that system to become precise enough that they can fail. Because agents are very good at producing plausible implementation. But plausible implementation is not the same as correct implementation. And it is definitely not the same as architecture preserving implementation. So I do not want the agent to be the source of truth. I want the source of truth to be a contract outside the agent. This is what I care about. The test told me there was a mismatch, the agent made the mismatch disappear. The formal model told me whether that disappearance was legitimate.
And again, this point here has nothing to do with AI, okay? If I am a manager or a senior developer, we hire a junior developer. We do not give him all the information because we're used to the business, we know how things work, and some of the details we forget about them when we give them the spec, so the student and or the junior engineer can work. So what he's going to do is going to work to make the test pass, but because we did not give him guardrails about which classes he was able to modify or not, then he's going to change the class that should not be changed and make the test pass. And he has done his job. So a human that cannot read your mind is going to make the same mistake as the AI. So this has nothing to do with AI. It's just good software engineering practices, and that's why I'm really upset about this video.
And in this case, it was not. That is a role I want the formal model to play in an agentic workflow. Not to replace prose, tests, or me reviewing changes, but to keep a condensed, reviewable source of truth close enough to the implementation that I do not lose touch with the system while the system keeps growing. If you made it this far, thanks for your time.
And I just want to reiterate, like, this is a small channel. He has 400 subscribers, and I'm not making this video because I'm jealous or because I don't like AI Nothing like that. It just really frustrates me when people forget the history of computing. I've studied long after I was already an engineer with 10 years of experience. I went back to the 70s, the 80s, the 90s, and I studied every hardware, every system, every software architecture that I could to see the evolution and how things were done. And it really frustrates me when people treat this new age of AI generated code, which is just copy pasting, by the way, as if it was something new and important. It isn't. So, my message is for this content creator, please do real software engineering videos. I know people are going to be interested in AI, and there is nothing wrong talking about that, but the message here is wrong. The problem you're talking about is just good software engineering versus bad software engineering. It has nothing to do with AI. And I want to take a time now to not only react to the video, but also show that I did some research to fact check myself and make sure that I'm not full of shit. So Google how agents break architecture, right? This is my search. First Reddit post here, discussion, what do we see? So it's just explaining exactly the same thing that was in the video. So it is writing some code, he writes the test, the AI change the code, the test pass, but the architecture is wrong. And we come here to this comment here. Even a human engineer would fail in this scenario. Write down your mental mapping, make the diagram, write the tech spec, put in the ticket, and let the LLM ingest it. You're asking why the LLM can't read my mind, which is exactly what I'm saying. With the parameters that you gave to the AI, even a human, if he was doing the work with those parameters, would have made a similar job, because there was nothing in the design document or spec to infer that some things were not meant to be changed. And the solution, as I said, is entirely valid. You can do it like this with a start time and a duration. Maybe you want to process things differently when the duration is 0, but fundamentally there is nothing wrong with doing this. Also, there is a little clarification that he say he did write this in markdown files before giving them to the large language model. So I'm not an expert on this. I don't use AI models. It's just not my taste. Maybe I'm too old. I don't think I am. It just I see a lot of nonsense, and with my experience, I can say that something that should be done in almost any situation is requirement analysis. So we are going to read this. In systems engineering and software engineering, requirement analysis focuses on the task that determines the needs or conditions to meet the new or altered product or project, taking account of the possibly conflicting requirements of the various stakeholders, analyzing, documenting, validating, and managing software or system requirements. Not only that, requirements analysis is critical to the success or failure of systems or software projects. The requirements should be documented, actionable, measurable, testable, traceable, related to identified business needs or opportunities, and defined to a level of detail sufficient for system design. So you cannot be designing a system without making a requirement analysis. That's just not how software development works. That's the first thing that I wanted to stress, because that's what I learned when I started as a software engineer with my first job working on client server architecture with databases. Requirement analysis is the first step, right? You cannot skip it. And furthermore, I want to jump onto normalization, because in the video he's talking about formalization a lot, and I think it's okay. Why talk about databases? Databases are about the data, and why is there such a thing as database normalization? This means that when you create your application, right, you have to design the data first. You do not worry about the code. You model the problem and the data structures that are holding the objects and the relationships with the different objects must be mapped early on and corrected. There are several normal forms, you know. This is unnormalized, and then there is a first normal form, second normal form, third, etc., etc. And each degree of normalization is adding constraint. We can read some of them. Scalar columns cannot contain relationship or composite values. Once you check that, you're in first normal form. Then every non-prime attribute has a full functional dependency on each candidate key. Attributes depend on the whole of every key, second normal form, etc., etc. And when you do this normalization step, instead of having, I don't know, something like, let's say you have a client, and the client maybe it's I don't know, it's a messaging app. Okay, so maybe the client has some messages, okay, and I don't know, maybe the client also has some friends, right? So here, let's say it's a user instead. It's a user, you store his messages and you store his friend list. But the friends, they are users too, okay? So you need, let's write it like this, are also users, okay? So if you architecture your data where you're going to, for example, have friend 1, friend 2, wait, that's not a 2, friend 3, and then suddenly you realize that you don't have enough space and you need more, right? If you limit your design to just 3 friends and then later on you need more, you have to change the database. And the problem is that this was the wrong design. What you need to do is to have a list of users, and here you must have another table that is users friends, where you put one user with another user, and that relationship is a friendship. That's a friendship table, right? So you get this is all users, okay, and then here is the friendship table, and with this you can have one user with how many friends that you need, because that's the correct design. This design where you have the username here, this is user table, the name of the user and the list of his friends, and then you need to create many fields here. That design is going to break because it's not the correct data structure. This is the correct data structure. So that's why data is important. And to finish this video, I want to show you just how serious I am, and actually it's in the software engineering Stack Exchange. So this code from Linus Torvalds, which is the creator of the Linux kernel. Bad programmers worry about the code. Good programmers worry about data structures and their relationships. So the question is, what interpretation of this possible makes sense? I don't know, this question is malformed. And what can be applied or learned from it? And the answer is really straightforward, okay? It might help to consider what Torvalds said right before that. Git actually has a simple design with stable and reasonably well documented data structures. In fact, I'm a huge proponent of designing your code around the data rather than the other way around, and I think it's one of the reasons Git has been fairly successful. I will in fact claim that the difference between a bad programmer and a good one is whether he considers his code or his data structures more important. And then there is a more detailed answer which we are going to read because this is important and this is relevant to what happened in the video, because defining your data structures is your job as a software engineer. It's not the job of the AI, because the AI will not read your mind if you have a data structure in mind. What he's saying is that good data structures make the code very easy to design and maintain, whereas the best code can't make up for poor data structures. If you're wondering about the Git example, a lot of version control systems change their data format relatively regularly in order to support new features. When you upgrade to get the new feature, you often have to run some sort of tool to convert the database as well. For example, when DVCS first became popular, a lot of people could not figure out what about the distributed model made merges so much cleaner than centralized version control. The answer is absolutely nothing, except distributed data structures had to be much better in order to have a hope of working at all. I believe centralized merge algorithms have since caught up, but it took quite a long time because their old data structures limited the kind of algorithms they could use, and the new data structures broke a lot of existing code. So, as you can see, it's exactly my example here. If you use the wrong data structure, eventually there will be cases where the data structure cannot handle your use case and you have to break it. Whereas if you pick the correct data structure, then your code will just scale because the model is correct. In contrast, despite an explosion of features in Git, its underlying data structures have barely changed at all. Worry about the data structures first, and your code will naturally be cleaner. So that's why I strongly believe that this video is slightly misguided. It's not the agent that is breaking the architecture. It's actually because you didn't define your data that the AI is able to pass the test and modify the code to pass the test. It's just doing its job because you didn't do your job as an engineer to define what the data should be. And this has nothing to do with AI. A human programmer would have done the same regardless, given the same constraints. So I really hope this content creator can improve future videos. There's nothing wrong about talking about AI, but you should not confuse what is an software engineering issue with what is an agentic coding whatever issue. And this video is not about agentic AI. It's about just bad engineering and not structuring your data and then wondering why the AI is able to break everything and your architecture doesn't make sense anymore because you didn't structure your data. Alright, I'm going to end it here. And if you enjoy this analysis and this reaction, please consider liking and subscribing to the channel. That helps a lot. Thank you.